Let's look at some quick practice with laws of exponents. They don't all come to us this way, but this is a pretty good form for practice. You have some sort of complicated expression with various exponents and you want to simplify it. So how are we going to do this? We need to use some of our rules. We've got various powers of a and b. We want to get these to combine, and we should be able to get it to just a single power of a times a single power of b. The first thing we can do is we can use the fact that when you have the product of two quantities raised to a power, then both of those get raised to that power. So this is where the bases are different, but the exponent is in common. Okay, and so I'm going to do it in 2 steps. I'm just going to use that rule first. You can, when you practice at this, you can do multiple steps at once, but we don't want to do that right now. So a squared, I'm just going to treat that as a thing. We're going to get into that in a second. B cubed is something, and I'm just saying the product of 2 things multiplied by itself 4 times. I'm basically just reorganizing those, as I show in the more introductory video, into put all the a squareds together, put all the b cubes together. Similarly, I can take that a to the 5th b squared all squared. That's going to be a to the 5th squared times b squared and then squared. Now I can use one of my other really important rules, which is when I take a squared and I raise it to another power. So this is a power raised to a power. Those powers multiply. Oops, that's not where that goes. And these powers, 3 times 4 is 12. These powers multiply, 5 times 2 is 10. And 2 times 2 is 4. And now I can recollect, can put those all together. And a to the 8th times a to the 10, we use our last rule, last of the really big rules, not the only rule left. That's a to the 18th. The exponents add. So this is really crucial. The bases are the same here. Maybe I'll just emphasize that by just doing one more quick little step. I'm rewriting it to put them together. You wouldn't usually have to do this, but just want to emphasize. Okay, so I'm putting them together because a multiplication is commutative. It doesn't matter what order we do things in. And now I'm using this rule that when you multiply exponential expressions with the same base, and it absolutely has to be the same base, those powers add. Now these guys have the same base and the powers add, and I get this. And that's about as simple as it gets. Okay. Next one, a little more complicated, a little more interesting powers, including negative exponent. And so let's look at this. And so the first thing I can do is very much like what I did in the first step last time. I can say, okay, that's x to the 6th all cubed times y to the 0 cubed. Well, you know what? I'm going to do one more thing as well, because this is just easy, just low-hanging fruit. Wait a minute. Anything to the 0, that's just going to be 1. Okay? So that's just going to be 1. I'm just going to write that as, 1 to anything is 1. It just goes away. So I could write it as y to the 0 to the 3 and kind of postpone thinking about that, but it's really good to use the fact that, like, oh, that's going to be simple. It's just going to go away. Then the next one is going to be x squared to the 5th, very much like the previous one, y to the 4th to the 5th. Now this x to the minus 30 is just kind of hanging out. I didn't combine it with anything, just to make it a little simple. But now we're ready to do our next step. So that's going to be x to the 18. Exponents multiply when you do 2 exponents one after the other. That's another x, and now it's x to the 10. And here's y to the 20th. And here's x to the minus 30th. Okay, we're getting close. Okay, so we've got x to the 28th. And then I'm going to put that other x here. Again, we can reorganize them. So I'm combining the 2 positive exponents first. You could do this a little more efficiently, again, but I wanted to just separate out the negative exponent issue. Okay. This is a great thing about exponent rules. Even though negative exponents are kind of an interesting thing, and we'll remind ourselves what this means in a second, they still satisfy these beautiful rules. In particular, when you have the same base and you have these 2 exponents, they do add together, but of course you have to add a positive and a negative in the usual way. So 28 plus a minus 30, I'm going to write that out very explicitly. Oh, hey, well, that's just another name for 28 minus 30. You get minus 2. Now, this is not a bad way to write the final answer. A lot of the time we really say, hey, negative exponents are cool once we get used to those. But what if we didn't want negative exponents? We wanted to remind somebody, well, what's the more basic understanding of that negative exponent? And by definition, a negative exponent just means 1 over. It is not a negative on the outside. It is 1 over. And of course, that summarizes pretty well as y to the 20 over x squared. So there's a good final answer with no negative exponents. All right, so now let's do one more. So putting in some negative exponents again, but in a little more interesting way. Okay, I'm just going to do the same thing though. And I could convert those negative exponents to fractions, to reciprocals, earlier than I'm doing here, but I really want to kind of illustrate that it's better to leave them as negative exponents. Negative numbers are simpler than fractions. And so I'm going to do it very similarly to how I did before. I don't know why I just copied that. That was silly. Okay. Okay. I'm distracting myself. So copied it twice because it's so nice. So I'm just going to break it out, those individual pieces. These guys all get to the 4th power. These guys all get to the 6th power. I'm going to put those powers together. Again, negative exponents don't do anything weird here. They do multiply. These exponents multiply. This is just z to the 4th. La la la. This multiplies. Again, negative exponent multiplies, not anything weird. All right, so now we'll collect those together. I think I'll skip the actual showing the collection step and say, hey, minus 4 plus a 30, that's x to the 26. Y to the 8th plus a minus 12. Ooh, 8 plus minus 12, or 8 minus 12. Ooh, that's a negative. Interesting. So interestingly, that even though there was some negative stuff for the x exponents, the positive one overwhelmed it. We're ending up with a positive exponent. The y's, different story. And then z, we've got a 4 and a 12. They add to a 16. And then, again, that is a really good way to write it for a lot of purposes, especially sort of later on. We learn to really love the negative exponents, and often we don't even worry about changing them. But it's nice to remind ourselves, hey, that negative exponent, it's a fraction. That's going to have some different feel in some ways from a positive exponent. And so there's our final answer.